Hello children, welcome to my dream. Today we are discussing the problem based on gravitation. Yes, the two bodies of masses m1 and m2 are identical initially at rest at infinite distance apart. Initially at rest, it means initial kinetic energy is zero. But at infinite distance, their potential energy will become zero, because that is huge, because u is equals to g m by r. At infinite distance, it will become zero. So, initial kinetic energy as well as the potential energy, both of them are zero. They are then allowed to move towards each other under the mutual force of attraction, and the relative velocity of approach at the separation distance between them. Okay, we want to discuss the relative velocity. As we are talking about the relative velocity in this case, there is a reduced mass system. So, the initial kinetic energy is zero, the potential is zero. Now, the potential energy is given by G m1 m2 upon R and their kinetic energy will become mu v square, which can be written down like this also, G m1 m2 upon R. In place of this mu, which is the reduced mass of the system which we have discussed and which is given by m1 m2 upon m1 plus m2. So, in place of mu, you can write down the reduced mass of the system, that is m1 m2 divided by m1 plus m2 into v square. So, this twice of g divided by r and m1 plus m2, which is equal to v square. So, v is equals to, take the square root, twice of g by r m1 plus m2, take the square root. So, which one is correct? B is correct. I repeat, when we are discussing the relative velocity in these type of problem, we must consider the reduced mass of the system. Now, three equal masses, each of small m, are at the corners of an equilateral triangle of side A. So, it will become 30. Here, AP is equals to BP, which is equal to CP, and that will become, this is A by 2, and that is cos 30 is equals to A by 2 divided by BP. So, BP is equals to Here the equilateral triangle is given to you. So you will get a by root 3. So a by root 3 is the distance between A and B, BP and CP. Now, the escape velocity of an object from the circumcenter P. Yes, by using the work energy theorem, or you can say the conservation of energy, it can be written down. This. Okay. Escape velocity of an object, yes, it can be, the potential energy is given by G m dash G m dash let m dash be the mass of an object. Small m dash is the mass of an object, divided by this, which is equals to multiplied by 3 because of this and that, and that is equals to half m dash v square, which is equal to 0. So half mv square, m dash will cancel, this is half v square G m by r is a by root 3. The value of r is a by root 3. This is the r, and multiplied with this. So v square is equals to 6 root 3 Gm by a, and take the square root. Then you will get v is equals to under root 6 root 3 Gm by a. So the C option is correct. We can go through the another method also. Escape velocity due to A, escape velocity of P with respect to A, escape velocity of P with respect to B, escape velocity of P with respect to C, which is equal to, the escape velocity is given by under root twice Gm by whatever the distance is, that is a by root 3. This is under root Gm by a by root 3 multiplied by 2, and third twice of Gm by a by root 3, and which is equal to twice 6 under root 3 Gm by a. And you want to know the escape velocity of it. So this is the another method, this one is the another method. Now the next question is, suppose the gravitational force varies inversely as nth power. The gravitational force varies as nth power of the distance. The time period of the planet in a circular orbit of radius r around the sun will be proportional to, and you want to know the time period. It can be written down k by this, that is mr omega square, that is the centripetal. This is the gravitational force. As it moves sun, this is the planet, so as the gravitational force is meant for attraction and the centripetal force acts toward the center, it will encounter it. Net force on the system will become 0, or you can say the system is in equilibrium. So k by r raised to power n mr omega square. In place of omega, you can write down n plus 1, it will move here, omega, that is 2 pi by t, in place of omega you can write down 2 pi by t. So square of the time period is equals to 4 pi square m divided by k r raised to power n plus 1, and this is a constant. All are constant. So this is square of the time period is r raised to power n plus 1. And you want to know the time period, so it can be written down n plus 1 divided by 2. The first option is correct. Now, the next question is, a point P lies on that axis at a distance capital R, and the radius is also capital R. A small particle starts from P, reaches at C under the gravitational force of attraction. Its speed at the center C will be. So first of all, this is the ring of mass capital M. Here a small particle of mass V small m. So this is r, so it will become root 2r. You know the Pythagoras theorem. So the initially the kinetic energy is 0. And the potential energy will be G capital M small m root 2r. Now, as it moves toward the center, then its kinetic energy will become half mv square, and the potential energy will be G m small m by this. So half mv square, this is G capital M small m by R minus G capital M small m by root 2r. Now you can take common, this will cancel out, this 2 will move here, so it will twice of G m by r, in bracket you can write down 1 minus root 2, which is equal to v square. 2 बेटे यहाँ चला गया, ठीक है बेटा. So v is equals to twice of Gm by r 1 minus 1 upon root 2. Yes. Here you see the option. In place of this you can write down capital M. So which one is correct? Which one is correct? This is capital M. So this one is correct. Take the square root. Now a planet was suddenly stopped. A planet was suddenly stopped in its orbit, supposed to be circular, the time it takes to fall on the sun. Okay? The time period of the planet revolution is T. If the time period of the planet revolution is capital T. So as you know, the Kepler's third law, the square of the time period is directly proportional to the cube of the semi-major axis. So T2 by T1 is equals to R2 by R1 raised to power 3 by 2. As it falls on it, so R2 by R1 can be written down 1 by 2. So in place of this you can write down 1 by 2 raised to power 3 by 2, that is T1, which will become 1 upon 2 root 2 T1. As it falls, the time it takes to fall on the sun, that is T1 is equals to, because it will become half. So in place of this T1 you can write down T2 is equals to 1 upon 2 root 2, and that is T by 2. So the answer is T by 4 root 2. Which one is correct? T by 2. This is root T by 4. No. Okay. If it is multiplied by root 2 and divided by root 2, so this will become root 2 into T divided by 8. So this is the time period to fall on the sun. Next. Infinite number of masses are given to you, each of mass 1 kg, and they are placed at certain distances. The several number of particles are given to you like this, either on the negative axis or on the positive axis. So this is at 1 meter, second one is of 2 meter, third one is at 4 meter up to infinity. The magnitude of the resulting gravitational force. We want to discuss the gravitational force. Okay. Gravitational potential. Gravitational potential is given by Gm by R. First is this is due to second and third. And potential is a scalar quantity, that's why we are following the algebraic sum. So potential at O due to first, potential at O due to second, potential at O due to third, and so on up to infinity. So Gm by R is of 1, Gm by R, that is of 2, Gm by R, that is 4, up to infinity. Then Gm common ले लीजिए बेटा. This is 1 plus 1 by 2, that is 1 by 4, and so on up to infinity. And this is the geometric progression. Geometric progression, the sum of the numbers for infinity is given by A upon 1 minus common ratio, where A is the first term and R is the common ratio. So the first term is given by Gm. The first term is 1. This is 1 minus 1 by 2. That is T2 by T1 or T3 by T2. So it will become twice of Gm and m is of 1 kg, so it will become twice of G. So this is the option C is correct. Option C is correct. Gravitational potential at x is equals to 0. Now, the option C is correct. The next question is, for the Earth and Moon system, let capital M and the small m be the masses of the Earth and small m is the mass of the Moon. The small v be the instantaneous relative velocity. Again he is using the term instantaneous relative velocity. It means we are talking about the reduced mass of the system. Then the total kinetic energy of the system in the center of mass free. So as I told you before, the total kinetic energy is given by half v square. There is no need to put small m because of the instantaneous relative velocity we are considering the reduced mass, and which is represented by mu. So the formula of the reduced mass that is m1, m2, this is. Here m1 is here, m1 is capital M and m2 is of small m. m1, m2. Then you can write down 1 by 2 capital M small m divided by capital M small m into V square. So the option A is correct. Now, a satellite of mass small m is circulating around the Earth. This is the Earth. The mass of the Earth is represented by capital M. This is a satellite of mass small m. A satellite of mass small m is circulating around the Earth with a constant angular velocity. If the radius of the orbit is r0 and the mass of the Earth is capital M, the angular momentum about the center of Earth is okay. As you know, if no external torque is applied on an object, the angular momentum remains conserved. Here, angular momentum is given by this. And the radius is r0. The mass of the satellite, that is small m, momentum m into v, and this is the orbital velocity, so v naught. V naught is given by under root gm by r naught. The orbital velocity is given by under root gm by r, whereas the sk velocity is given by under root twice of gm by r. So m gm r naught square divided by r naught cancel, then you will get small m under root gm capital M r naught. So which one is correct? Option A is correct. Yes, this one. Now, the condition for a uniform spherical mass small m of radius small r to be a black hole. When we are talking about the to be a black hole के बारे में डिस्कस कर रहे हैं. Then, if light not escape in this region, that is the black hole. Where c is the speed of light, and which is possible when the sk velocity is greater than or equals to speed of light. and escape velocity is given by twice of gm by r under root, which can be write down gm by r raised to power 1 by 2, which is greater or equals to this. So gm by r, yes, this one is D is correct. D is correct. Yes, the earth E moves in an elliptical orbit. This is the earth which moves in elliptical orbit with the sun S at one end of the foci as shown in figure. The speed of the moon will be maximum. This is perihelion, this is aphelion, this is the closest distance between the planet and the sun. This is perigee, this is apogee. But you know, all the planets revolves around the sun in an elliptical orbit, and which is given by gm by r, and these are the constants. These are the constant. So V is inversely proportional to this. So speed will be maximum. Speed will be maximum at A, because this is very much smaller as compared to other points. Now, if the change in value of G at a height h, as you know, effect of height, effect of depth, effect of latitude, as we are moving away from the center of earth, gravity goes on decreasing. As we are moving toward the center of earth, again gravity decreases. At the center of earth, gravity will become 0. But in this question, he is saying if the change in the value of G at height h above the surface of earth is same at the depth x, it means GH is equal to GD. Gravity at the height h is equals to gravity at the depth x. For the small change, you can write down 1 minus 2h upon r. This is 1 minus d by r. One minus 2h by r, 1 minus d by r. So twice of h by r is equal to d by r, and depth d is x in this question. So 2h is equal to d and d is equal to x. So twice of h is equal to x. ठीक है? तो x is equal to क्या हो गया बेटा? Twice of h. The next question is This is R. This is not P2, P1. This is rho 1, rho 2. This is the R1, rho 2, R2, rho 1. Similarly, you can write down here R1, rho 1, R2, rho 2. In place of this, rho 1, rho 2, you can write down. Here it is P1, P2, not P1, P2, that is rho 1, rho 2. The radii of the two planets are respectively this and that, and their densities are respectively rho 1 and rho 2. So, as you know, the gravity in terms of the mean density, if we are talking about the depth, gravity in terms of mean density is given by small g is equal to 4 by 3 pi capital G R rho. Here the two planets are given to you. Let it be G1, another one is G2. That is 4 by 3 pi capital G for both same. This is R1 rho 1, this is R2 rho 2. R1 R2 the radius of curvatures, radii, rho 1 rho 2. So it can be written down G1 is to G2. Say R1 rho 1 to R2 rho 2. Now, which one is correct? Option D is correct. Now, the depth D, the depth D at which the value of acceleration due to gravity becomes 1 upon n times. So, gravity at the depth D will become this. So, GD upon G is equal to 1 by L. As we know, GH by G, that is 1 minus D by R. So, in place of this, you can write down 1 by L. 1 minus D by R. So, D by R one minus 1 by N. Take the LCM. N minus 1 R. So, this is the depth. This one is correct. Option B is correct. Two small heavy spheres, each of mass capital M, are placed at a distance this apart on a horizontal surface. The gravitational potential at the midpoint and they are separated by a distance, each of mass capital M. This is the position A, this is B, and you want to discuss the potential at this. Here we want to discuss the gravitational potential at the midpoint. So, the gravitational potential is given by Gm by R. Here, potential at O due to A plus potential at O due to B, which gives V. Potential at O due to this, that is given by capital G, capital M and distance will become r by 2. Gm r by 2, so it will become twice of Gm by r, twice of Gm by r, it will become 4 Gm by r. And my dear, potential कैसा है? Negative. So it will become minus. ये रहा minus. Now, so option D is correct. Four particles each of mass capital M are located on the vertices of a square with length L. The side of square is represented by capital L. So there is a square, length that is L. The four particles each of mass capital M. The gravitational potential at the center we are discussing. This is A, B, C, D. This is it. This is L, this is L, this is L root 2. This is L by root 2. So OA is equal to OB, which is equal to OC, that is equal to OD, which is equal to L by root 2. So gravitational potential, potential at O due to A, potential at O due to B, potential at O due to C, potential at O due to D. And this is minus Gm by R. In place of R, you can write down L by root 2. L by root 2. L by root 2. This is Gm L by root 2. Gm L by root 2. This is Gm L by root 2. This is 4 Gm by L by root 2. So the answer is minus 4 root 2 Gm by L. माइनस 4 रूट 2 Gm बाय कोई ऑप्शन ही नहीं है, तो इसको कर लेते हैं बेटे। माइनस इसको अंदर ले जाते हैं बेटा, स्क्वायर ऑफ 4 16 2 जा 32, दैट इज Gm बाय L. आंसर इज माइनस 32 Gm by L. So the option D is correct. Option D is correct. Three particles each of mass small m, which is given to you, are kept on the vertices of an equilateral triangle of length L. There is a presence of the three particles each of mass small m. This is the length L. The gravitational field, either you can say gravitational field or gravitational field intensity. The gravitational field intensity either represented by I or E, that is Gm by R square. And you want to discuss the gravitational field at the center. At the centroid you can see. This is the position A, this is B, this is C. This is O. OA is equal to OB, which is equal to OC. In the previous problems we have already calculated. So that is L by root 3. That is R. So intensity I2 ये वाला जब इस पर डिस्कस करेगा इंटेंसिटी तो एरो किधर आएगा बेटा? Intensity at O due to B. Intensity at O due to B. That is given by Gm upon Gm by L by root 3. So it can be written down this intensity. This is I2. Intensity at O due to 3. थोड़ा सा चेक कर लेते हैं. This is 2. Intensity at O due to B. This is B, not 3. Intensity at O due to C. Due to C. 3 भी बोल सकते हैं, कोई बात नहीं. That is Gm by L by root 3. So this is Gm by L root 3. And you see this is equal to this. Intensity at O due to C, arrow इधर आगे बैठे. And resultant of these two will become I dash. This is 30, this is 30, so it will become 120. A vector, आपने पढ़ा था, a vector A is equals to B and theta is equals to 120, the angle between A and B, then the resultant must be equal to A is equal to B. A square by B square plus 2AB cos 120 minus 1 by 2. So, I dash vector I2 plus I3 vector. I2 square plus I3 square 2I2 I3 cos 120. Here I2 is equal to I3. So in place of I3 you can write down I2. In place of 3 you can write down 2. So it will become I2. as I told you before, a vector A is equals to vector B, and the angle between vector A and vector B is 120 degrees, then the resultant must be equal to either A or B. That is under root 3 gm by L. Now, intensity at O due to A, arrow will be upward, and this is same. I1 is also same. So I1 is equals to I2, which is equal to I3, that is equal to I dash, and which is under root 3 gm by L. And I1 is anti-parallel to I dash. If vector A is equals to B and theta is 180, then you will get A minus B. Got it? So I is equals to vector I1 plus vector I dash, which will become I1 minus I dash, and you see I1 is equals to I dash, so it will become 0. It will become 0. The option A is correct. Option A is correct. Now, two spheres of mass small m and capital M. Two spheres of mass small m and capital M in A, and the gravitational force between them is F. The gravitational force between them is capital F. The space around the masses is now, first of all, they are in air. Now filled with the liquid. आपने कोई liquid fill कर, whose specific gravity is 3. Now the gravitational force will become, there is the presence of the two spheres, one of them having the mass small m, another one having the mass capital M. They are kept in air, whose magnitude is capital M. That is the gravitational force. The magnitude of the gravitational force is capital F. Now these two spheres are placed in a liquid whose specific gravity is 3. My dear, gravitational force do not depend upon the medium of the mass. So it will remain same. Gravitational force do not depend on the medium in which the objects are placed. So it will remain the same. That is capital F. So the first option is it. Gravitational force do not depend upon the medium in which the objects are placed. It depends upon the masses of an object, not the medium of the object. किस मीडियम में रखा है क्या है. two particles of equal masses, there is a presence of the two particles of equal masses, go around a circle of radius r, go round of a circle of radius capital R. This is a capital R. Equal masses, this is small m, this is under the action of their mutual gravitational force of attraction. ये यहाँ तो दूसरा यहाँ होगा, ये यहाँ तो दूसरा यहाँ होगा. And the speed of each particle, you want to know the speed of each particle. So first of all, we are talking about the gravitational force, that is G m1 m2 upon r square. Here, the gravitational force is given by m into m, small m into small m, so it will become m square. R is the radius, so it can be written. And the centripetal force, as they are go round a circle, then the centripetal force is given by mv square by r. The system is in equilibrium, so net force is 0. So this is equal to that. And in place of r, you can write down r, capital R. Now you see, the distance between this and that is twice of r. That is twice of r, not the capital R. Not the capital R. That is, यहाँ mistake करेंगे आप. That is 2. So Gm square by 4r square, that is mv by r. Gm by 4r, take the square root, so C option is correct. Two satellite of masses small m and 2m, एक ये है, दूसरा ये वाला है. एक सैटेलाइट ये है जिसका मास स्मॉल m है, इसका मास ट्वाइस ऑफ m है. Around a planet of mass capital M with different speeds in the orbit of radii r and 2r. The ratio of the minimum and the maximum. The minimum, the force will be minimum. जिसका रेडियस ऑफ रेडियस कम होगा उसका ग्रेविटेशन फोर्स क्या हो जाएगा, ज्यादा हो जाएगा. तो G capital M, small m is the mass of first object and the distance is r. इसका डिस्टेंस ज्यादा है तो कम हो जाएगा. Gm into twice of m, distance is of twice of r. समझे? Now G m small m by r square. This is G m small m by 2r square. Then you will get G m small m by r square 1 minus 1 by 2, which is equal to G m small m by 2 r square. The minimum force. Maximum would be, maximum कब होगी? जब हम दोनों को ऐड कर देंगे. G m small m by r square. Here the m mass is of twice of m. Add कर. Then you will write down 4. So it will become G m m by r square, G m small m by 2r square, G m by small m by r square 1 plus 1 by 2, which will become G m small m by r square, that is 3 by 2. This is 3 by 2, this is 1 by 2. ऐसे लिख लीजिए. Minimum upon maximum, F minimum, F maximum, because you want to know the ratio of the minimum and the maximum. So 1 by 2 तो कैंसिल हो जाएंगे ना बेटा, ये वाला इससे कैंसिल हो जाएगा. 1 by 2 divided by 3 by 2, then you will get 1:3. That is 1 by 3, you can say. Which one is correct? C. The C option is correct. Now, in the figure, the space shuttle is initially in a circular orbit of radius r. About the, at the point P, the pilot briefly fires a forward pointing thruster to decrease the shuttle kinetic energy. To decrease the shuttle kinetic energy, which of the shaded, which of the bases elliptical orbit with the shuttle then took? So my dear, kinetic energy decrease कर रही है. क्यों decrease कर रही है? Due to the forward thrust. Due to the forward thrust, its reaction decreases its speed, because mass तो vary करता नहीं है. Kinetic energy half mv square, there is no change in the mass. So you can say, due to the forward thrust, its reaction decreases its speed. So जिसका रेडियस ऑफ कर्वेचर कम होगा, at that point, so the path first is possible. Otherwise, You see, there is the decrease in kinetic energy, or you can say there is the decrease in speed because of the forward thrust. So the first option is correct. Two spheres each of mass capital M. Two spheres each of mass capital M are situated at a distance 2d. A particle of mass small m, which is much smaller than the two spheres, is taken along the path shown in figure. ये यहाँ से यहाँ गया, ये से इधर गया, फिर इधर गया, फिर इधर गया, फिर इधर आया. So the work done in the process from A to B, as you see, the mass of the spheres are same. The test mass, that is small m, as it reaches here by following this path, then the potential at B with respect to A, or you can say potential at A with respect to B, they are same. So V is equals to W by M naught. So W is equals to VAB into small m. And there is the potential difference, that is VA minus VB. But my dear, potential at O due to A, potential at B due to this, then VA is equals to VB. So W is equals to 0. Option I. Yes, option D is correct. Now the next question is, gravitational field strength or intensity, gravitational field intensity, gravitational field strength, that is, आपको पता ही है जी, mass capital M, radius R, varies with the distance from the center. This is the solid sphere. Radius is of R. If you want to discuss the gravitational field strength at a distance, if we are considering this at a distance A, you want to discuss the gravitational field intensity at this point. So gravity is G dash is given by GR upon R. For R is very much smaller than this. Now G dash, you want to discuss the gravity at this point. It means for R is greater than and equals to this, and that is given by G upon, आपने पढ़ा होगा 1 plus H by R. Here H is small r. So this is ग्रेविटी लीनियरली इंक्रीज कर रही है up to capital R, and after that is decreasing. Linearly, this will be possible, it will be possible, but as you see, the gravity goes on decreasing, so this one is correct, not this one. Yes, these are the problems which we have already discussed today. The practice problem based on gravitation. In the next session, we will discuss the rotational motion, or you can say rigid bodies. Okay.